Trig ratios to find unknown side lengths. So first thing, in your calculators, make sure that this symbol right here should say DEG for degree. So to do that, you'll have to hit I think this button right here for degree, and it should pop up. But most of the calculators should already be in degree mode. And then right here is our sine, cosine, and tangent buttons. And that's what you're going to be using. So like in the picture, make sure whenever you use sine, you have parentheses about whatever our angle is, and everything else needs to either be in front or like times it. Okay, and then another reminder, our tenths place is the second spot after your decimal point, and 10,000ths is the fourth spot. So using the measure of angle A is 22.62 degrees. What is the sine, cosine, tangent ratios for angle A in simplest form and as a decimal to the nearest 10,000th? And then we're going to use a calculator to check them. So this time, we know that angle A is 22.62, but our ratio is still the same. So here is our opposite, our hypotenuse, and our adjacent. So sine is going to be opposite over hypotenuse, so that's going to be 5/13. If we plug that in our calculator, 5 divided by 13th gives us 0.3846 when we round. Let's see if I can change this. So 5 divided by 13, we get 0.3846. Now let's do cosine. So cosine is going to be adjacent over hypotenuse. So 12 over 13. 12 over 13 gives us 0.9231. So make sure we're rounding correctly. If it's 0 to 4, you round down. If it's 5 to 9, you're going to round up. And then tangent of 22.62, that is 5 over 12. So that's going to get us 0.4167. Okay, so it's 0.666, but we rounded to get up to 7. And then now we can actually check all of these in our calculator. So here's where you're going to use your sine. So now do sine of our angle. So sine of 22.62. See how that matches what we got for our ratio? Cosine of 22.62. So all of these will end up matching what we've gotten. So they all check out. If you're on your phone and you want to download this calculator app, Numworks, it's awesome. And then see how my calculator is in degrees. Okay, so how can we check if our calculator is actually in degree mode? Maybe you don't have the calculator I showed. You can check by entering tangent of 45. Tangent of 45 is always 1. So that's one way to check is your calculator in degree mode. So now we're going to enter all these in, and we're rounding to the 10,000th. So sine of 10 degrees is 0.1736. Sine of 75, 0.9659. If you want to take a calculator and calculate these along with me, so that way you're understanding how to use the calculator when you do your homework, I suggest doing that. Cosine of 60, 0.5 or 1/2. Cosine of 80 degrees, 0.1736. Tangent of 8, 0.1405. and tangent of 88. 28.6363. Okay, so that is how we find our ratio using a calculator. Now on to our application problems. We're going to try and find side length of triangles. So here's like we talked about the other day. How can we find x? We can't use Pythagorean theorem. We can't use our special right triangles. Here's where our cosine, sine, and tangent ratios come in place. So this angle right here is our reference angle. So that means x is our opposite, and 19 is our hypotenuse. So sine works with opposite and hypotenuse. So the sine of our angle, so sine of 28, is equal to x over 19. Now we have to solve for x. So to solve for x, one way is we just put this over 1, and we solve by cross multiplying. So we get x equal to 19 sine of 28. So now that x is by itself, this is where you're going to take your calculator and you're going to put 19 sine of 28. So we get x is equal to 8.9. So this time it only wants us to round to the nearest tenth, so that's 1 decimal place. So 8.9. And does this make sense? If this side length is 8.9, yep, that looks like a reasonable answer because our hypotenuse should be our longest side. We shouldn't get anything larger than 19. Okay, our next problem. So here's our reference angle. So across from that, that is our opposite. And then our 32 is our adjacent. So tangent goes with opposite and adjacent. So tangent of our angle, so tangent of 41 is equal to x over 32. Now we're going to solve by cross multiplying. So you get x is equal to 32 tangent of 41. So let's type that in our calculator. 32 tangent of 41. So we get x is equal to 27.8. And does that make sense? If this whole length is 32, this length being 27.8 seems reasonable. Okay, our next one. So 64 is our reference angle. So that means this 42 is our opposite. And x is our adjacent. So this is another tangent problem. So the tangent of 64 is equal to 42 over x. So again, let's solve it by cross multiplying. So now we get x tangent of 64 equal to 42. But again, we want x by itself. So what we're going to do is we're going to divide by the tangent of 64. So what happens here is these tangents cancel each other out, leaving us with just an x. So now we have x equal to 42 divided by the tangent of 64. So in your calculators, you're going to type 42 divided by tangent of 64, like that. Mine makes a nice little fraction for me, so I don't have to use as many parentheses. So we get x is equal to 20.5. Okay, so it was 0.48. Make sure you round correctly, so 20.5. And then does that make sense for our side length? Yeah, because this one is 42. This one looks like about half the size. So 20.5 would be a reasonable answer. Okay, flip the page. Okay, 33 is now our reference angle. So across from 33 is our opposite. Across from your right angle is your hypotenuse. So sine works with opposite and hypotenuse. So the sine of 33 is equal to 15 over x. So now we're going to solve by cross multiplying. So we get x sine of 33 equal to 15. Now we're going to divide by sine of 33. Again, our signs cancel, leaving us with x equal to 15 divided by sine of 33. So we put that in our calculator. We get x equal to 27.5. So there is a little bit of a pattern going on here, some of you might notice. If we look back at here, we have, if we ever have x in the bottom of our fraction when we set up our original ratio, when we solve, if we look, our x and our sign ended up flipping place. So now our x and our sign are flipped. So that's something that we can do. We can start using instead of timesing by sign and dividing by sign every time. You can use that method if you want and you see that pattern. Okay, now we have two triangles here. So in this triangle, we actually have to find this middle length first before we can find x. So let's call this y, so we can find y first. So here's our reference angle, angle 39, so that means y is your opposite, and 38 is your adjacent. So that's going to be tangent. So tangent of 39 is equal to y over 38. Okay, if we cross multiply, we end up getting y equal to 38 tangent of 39. So let's plug that in our calculator. So we get y is equal to 30.8. Make sure we're rounding up. So right here, instead of y, I'll leave the y there. This is 30.8. Now, in this triangle, we have a known side and an angle we can find x. So now 60 degrees is our new reference angle. That makes now 30.8 your opposite, and x is hypotenuse. Opposite and hypotenuse is sine, so sine of 60 is equal to 30.8 over x. Okay, remember what I just said from the last one? If you notice this pattern of x being on the bottom, the sine and the x can switch spots. So x is equal to 30.8 over sine of 60. So we end up getting 35.6 for x. Okay, our next one. So we have, again, we define this middle length first before we can find x. So 35 is our reference angle, so 9 is our opposite, and y is our adjacent. So that's tangent, so tangent of 35 is equal to 9 over y. So there's that pattern. Our variables on the bottom, so we can flip them. So we get y equal to 9 over tangent of 35. So y is equal to 12.9. So in this length, we have 12.9. Now in this new reference angle, x is our opposite, and 12.9, that's still our adjacent. So it's another tangent problem. So tangent of 61 is equal to x over 12.9. So we end up getting x equal to, okay, cross multiply, 12.9 tangent of 61. 12.9 tangent of 61. We get x equal to 23.3. Okay, find RS. So one thing about trig ratios, you can only use them in triangles that are right triangles. So previously we've been finding this middle segment But in this triangle, PSR, this is not a right angle. So which means to find RS, what you have to do is you have to find QR and then subtract QS, because we have a right triangle here. Oops. We have a right triangle here and a right triangle here. So first, let's find this segment. We're going to find QS. So 32 is a reference angle. So this means this is our opposite and this is our adjacent. So tangent of 32 is equal to y over 14. So you get y is equal to 14 tangent of 32. So y is equal to 8.7. So this is 8.7. Now we're going to find this whole length, and we'll call this W. And that means we're going to use this entire angle. So 32 plus 24 gives us 56 degrees. So this whole length is opposite, and we still have an adjacent. So now tangent of 56 is equal to W over 14. So W is equal to 14 tangent of 56. So W is equal to 20.8. Now our last step is to find this segment right here. So to find RS, we're going to do 20.8 minus 8.7. 20.8 minus 8.7 gives us 12.1. Okay, 2 word problems left. So how long is the guy wire that if it is attached to the top of a 150-foot tower, it makes a 42-degree angle with the ground? So 42-degree angle with the ground, that's this angle right here. That's 42 degrees. We want to find how long the wire is. So here is our X. So here's our opposite and our hypotenuse, because the tower makes a 90-degree angle with the ground. So the sine of 42 is equal to 150 divided by X. So here's that trick I said, if there's a variable in the bottom, we can flip these. So we get X is equal to 150 divided by sine of 42. So get X is equal to 224.8 feet. Okay, it says to round to the nearest tenth, so 0.8. Oh, sorry, 0.2. Okay, Daytona International Speedway has a banking of 31 degrees in the corners and a track width of 40 feet. What is the vertical height of the track? So the vertical height would be this length right here, so that's our X. So using our reference angle, X is our opposite and 40 is our hypotenuse, so that is going to be sine. So the sine of 31 is equal to X over 40. So we get X is equal to, if we cross multiply, 40 times sine of 31. So X is equal to 20.6. Okay, and then that is it for notes today. So then your homework is going to be this first page, just the front, so finding missing side lengths with trigonometry. So you're going to do 1 through 15, and here's your answer bank. You can check your answers, so just the front. And then I want you guys to try starting this facing math worksheet. So if you can get through the first page, so go through 12. And then when you solve, you'll get one of these answers. And you'll have lots of time to work on this facing math, so I want your priority to be getting this worksheet done, okay? And then just hold on to them, and we'll go over questions when I get back.